Moving on to the next part of this section, we're going to look at division. And division and multiplication are related, very similar to how addition and subtraction are related. And in fact, where multiplication can be thought of as repeated addition, division can be viewed as repeated subtraction. So this first image that I have here, which is also sometimes called division by grouping, you might hear that, or even measurement division. We're going to show 28 divided by 4 with repeated subtraction. So I've got 28 little stick figures of people here, and we're going to be pulling them out in groups of 4 to show the 28 divided by 4. And as we pull them out, we're going to be subtracting. How many are left? So when you pull out the first group of 4, 28 minus 4, you're left with 24. Pull out a second group of 4, what are we down to? 20. And you're just going to keep subtracting down until you get to 0. How many times did you have to subtract 4? Well, in this case, 7 times to get down to 0. So 28 divided by 4 equals 7. So that's how division can be shown as repeated subtraction. You can also show division with the partition model. This is sometimes called partitive division or even division by sharing. So here we have our same 28 little figures. Here we're breaking them again into 4 groups. How many people then are in each group? 7. Okay, so it's just another way to look at that same exact problem. Now, when we're dealing with division and multiplication, we can form fact families. So just as we had fact families for addition and subtraction, you can do the same thing for multiplication and division. And in this case, we know that 4 times 7 is 28. Commutative property tells me that I could also write this as 7 times 4 is 28. With division, we have 28 divided by 4 is 7, and 28 divided by 7 is 4. There's our fact families. And that leads us to this definition of division in whole numbers. So you're going to see within this definition our fact families. So we have division defined this way. Let A and B be whole numbers with B not equal to 0. We cannot divide by 0. We'll actually get to this Y in just a moment here. So as long as B is not equal to 0, we can define division this way. A divided by B equals C. If and only if, we can rewrite this as multiplication. A equals B times C for a unique whole number C. That word unique is important. This only works if there's one number that is going to be our quotient. For instance, I can't say 28 divided by 4. It could be 7, but it could also be 6. Maybe it's 8 some days, okay? There's one answer there. There's no guessing in this. Now, when we're dealing with division, the answer, if you will, is called the quotient, and I'm sure most people are familiar with that. The other two terms, the two numbers that are being divided, the first one is the dividend, and the second number is the divisor. So the dividend divided by the divisor equals the quotient. And I have these terms as well as the other terms for the first two models in the PDF of my notes. So you can go there and look for those, the spellings of those terms if you need them. I want to look at why division by 0 is undefined. And I have the proof written out here. I didn't want to make the video unnecessarily long by you just watching me write all this out. And again, I have this in the PDF of my notes because I'm going to probably read through this quicker than you could write it down. but we're going to show why division by 0 is undefined. Now, when you're trying to divide by 0, okay, we're going to take, instead of a divided by b, we're going to do a divided by 0. And we're going to look at two cases. We're going to look at the case where a is equal to 0, and we're going to look at when a is not 0. There's no other options for a. A is either 0 or it's not. So we're going to look at both cases and show how division by 0 does not work in either case. I'm going to start where a is not equal to 0. So by the definition that we just looked at, there should be some number c, okay? So a divided by 0 equals c, which means that a is equal to 0 times c. The problem, though, we talked about this when we talked about multiplication. 0 times c is going to equal 0. So that would mean that a is 0, but we said a is not 0. So we have a contradiction. Therefore, a divided by 0 is not defined for a not equal to 0. So there's our first part of our proof. That deals with a not equaling 0, but there's that one other case left when a equals 0. So we're going to look at that. Going back to that definition again, and this is where that word unique comes into play. By definition, there should be a unique number c such that 0, that's our a, equals 0 times c. But 0 times c equals 0 for all values of c. It's not just one number c. Anything you plug in there, 0 times 4 is 0, 0 times 17 is 0. We don't have a unique value c, and that word unique is important. Because we don't have a unique c, we say that a divided by 0 is not defined for a equals 0. Since a is either equal to 0 or it's not, we've considered all the cases and shown that division by 0 is undefined across the board. Said this in other videos. This is not something that you would be necessarily teaching to elementary students, but it's good for you to have that background knowledge for yourself. You don't want to say, well, it's not defined because it's not defined. Now you know why it's not. So I wanted to give you that. One last thing we'll look at in this video, and then my next video we'll do a few examples with division, is division with remainders. So here I have some tiles here. The first one, it's 27 divided by 5. 27 divided by 5. So you can take these tiles, put them into groups of 5. So there's 5 groups of 5 and 2 left over. Those 2 left over are the remainder. In the second picture here, we've got 27 now divided by 4. When you're dividing by 4, you can form groups of 6. Or rather, sorry, I said that backwards. We have 27 divided by 6. So we're able to form 4 groups of 6. Once again, we have a remainder of 3 left over. So very easy to show division with remainders with our blocks. And then we have a more formal definition as well. When we have a remainder, you've got our quotient, which we're calling Q, and then our remainder R. When you divide A by B, you get a quotient and a remainder. You can write it as A equals the quotient times B plus the remainder. And in the next video, we're going to look at a couple examples using this division algorithm. So we're going to come right back to that.